Hey guys, this is Speed Day 8, and this is part 2 of that video. So if you missed part 1, make sure you go back and find that. Okay, let's just continue where we left off with number 3. And you can see I've already got my D1, S1, T1, my D2, S2, T2 down here on the side, and you should be doing the same on your paper just to make sure that you keep everything organized. Okay, a sports car travels from A at a speed of 84 kilometers per hour and reaches B in 1.5 hours. A normal car travels at 2/3 of the sports car's speed. How many hours does the normal car take to reach B? Well, let's label some in our word problem. Here's our speed 1, 84 kilometers per hour. So we'll go ahead and write that down here as well. And here's our T1, 1.5 hours. And we don't have a D1 yet, but we've got the speed and the time, so we know we can find that. It says a normal car travels at 2/3 of the sports car's speed. How many hours does the normal car take to reach B? So we're going to label T2 with a question mark. We're going to label this 2/3 with an S2. Okay, well, first thing we need to do, obviously, is find the distance from A to B. So we can find that easily enough. We're going to use our distance formula, speed 1 times time 1. Since we have 2 out of the 3 variables, we can find the third. So we're going to multiply 84 kilometers per hour. And I'm actually going to set that up as a fraction because I'm going to multiply it by 1.5. And to turn 1.5 into a fraction, just multiply 2 times 1, and that gives us 2 2's, and then we add the 1, that gives us 3 2's. Okay, or 3 halves, excuse me. So we'll multiply that by 3 halves, and I'll do that math over here. 84 times 3 is going to be, let's see, 3 times 8 is 24 plus 1, 252. And we're going to divide that by 2. So that's going to equal 126. Okay, so let's mark that up there as well. 126 kilometers. And we'll plug it into our charts over here, and it's the same for both D1 and D2 because the distance from A to B doesn't change. Okay, now we need to find, so the ultimate question we want to answer is how long does it take that normal car to reach B? So I've got a question mark there, but we only have 1 out of the 3 variables, so we can't find the third yet. So we need to figure out what speed is on that. And it's set up here in my word problem that a normal car travels at 2/3 of the sports car's speed. So we're going to go ahead and, we're not using a speed formula per se, we're just going to find what 2/3 of 84 kilometers per hour is. Okay, so let's go ahead and do that. 2 times 84 is 168, and we're going to put that over 3. And let's do that math over here. 168 divided by 3, 3 goes into 6 5 times. Multiply that out. Bring down that 8, and 3 goes into 18 6 times. So my speed 2 is going to be 56 kilometers per hour. So let's go ahead and write that back in here. Now we are set to find time 2. So I have run out of room on my slide here, so I'm going to have to do time 2 down here. So that's going to equal distance 2 over speed 2, which is 126 kilometers over 56 kilometers per hour. And let's go ahead and let's do that math over here. 126 divided by, 56. 56 is going to go in there twice. 2 times 6 is 12. 2 times 5 is 10, plus 1 is 11. And let's subtract. We get 14, and we'll bring down a 0, and 56 goes into 140 twice, I'm going to end up with 112 here again. I'm going to need to bring down another 0, but let's subtract first. Okay, 56 goes into 285 times. Just to check, 5 times 6 is 30, 5 times 5 is 25, plus 3 is going to be 28, so I'm good there. So time 2 is going to be 2.25 hours. Okay, I hope you guys can see how easy life is when you keep all of your variables organized like this over here. And I'm even going to plug that back in here. Okay, let's do the next one. This next problem is really interesting. You should read through this problem and make a plan. See if you can figure out how to do this, because this is a really challenging one. So just make a plan and then come back and do it with me. Give it a try. Okay, let's do this together. All right, so it says a train is 143 meters long. It moves toward a tunnel at a speed of 15 meters per second. Let's just take a break here for a second and write our chart. Okay. It takes 3 minutes and 42 seconds for the entire length of the train to pass through the tunnel. How long is the tunnel? Okay, so let's actually draw a model on this one, and I'm going to actually draw the tunnel here. So here's my tunnel, and I'm going to just kind of draw a point at both ends so we can sort of draw a line through there so you can see how the train is approaching. Okay, so when we do this problem, it's going to be easier if we convert the time into seconds. But before we do that, let's go ahead and write what we know in here. All right. So the time is 15. Where's the time? Here's the time right here, 3 minutes and 42 seconds. And the speed is 15 meters per second. I'm not going to write my time down there quite yet because I want to convert that. So let's do that over here. So if we have 3 minutes and 42 seconds, first of all, let's convert the 3 minutes into seconds by multiplying it by 60. Okay, so 3 times 60 is going to be 180 seconds, but there were also 42, so it was 3 minutes plus 42 seconds. So let's add that on. Oh, my pen's gone goofy. 8 plus 4 is 12, and we get 222 seconds. Okay, the reason I did that is because my speed was given in meters per second, and so I couldn't very well work with my time there that in just minutes and seconds. We needed to have that converted, just using 1 unit. Okay, now we're trying to find the length of the tunnel. We're trying to find how long the tunnel is. So let's go ahead and let's use our distance formula. So distance is going to equal speed times time, which is 15 meters per second, times 222 seconds. Okay, so we've got some work to do. Let's figure out what 222 times 15 is. And you can see over here I've done that work. So 222 times 15 is going to be 3,330, well, not seconds, but meters. Okay, let's just think through this for a second though. If the train is moving towards here, right? Once it gets to the other end, the distance that you got right here is going to be the distance of the tunnel plus the distance of the train until the last bit is out of there. So here's my train, right? These are windows, you guys. Okay, so the reason that your word problem gives you that length right there for the train is because you're going to have to go back and subtract that from the distance. So when you get that 3,330 meters, that's this entire distance right here. So let's go back and subtract 143 from 3,330. Okay, and so I've done that work for you right there. So hopefully that's what you got, 3,187 meters. I hope you got that on your own. This is a fun problem that really requires some thought. All right, we're going to do one more together. All right, let's go ahead and we're going to skip number 5. I think you will be able to do that one on your own after we do number 6 together. 6 says, cities W and Z are 280 kilometers apart. A train traveled for 3.5 hours and covered 75% of the whole journey. Find the average speed of the train. Whoa, okay. So let's see, let's go ahead and draw a model. And we've got W and we've got Z right here. And they are 280 kilometers apart. And it says that the train traveled for 3.5 hours and covered 75% of it. So here is the distance that the train covered. Let's go ahead and write in some variables here. Let's just take a break really quick. Let's see, 3.5 hours is going to be our time. And let's see, we don't know the speed, do we? Because that's what we want to know. Now, we actually don't exactly know the distance yet either, do we? Because we're given a distance of 280. However, that's the entire distance, and we can see from our word problem that the train did not cover the entire distance. So let's figure out what that is. And let's go ahead and we can use unitary method for this. So 4 units is going to equal 280 kilometers. So 1 unit is going to be 280 kilometers over 4, which equals 70 kilometers. Okay, now I want to solve for 3 units. 3 units equals 70 times 3, which is going to equal 210 kilometers. Okay, so now we know our distance. We'll fill that in over here. 210 kilometers. Okay, well, now we can find speed, no problem. So let's use our speed formula. The average speed is going to be distance, which in this case, oops, we got to write the formula first, of course. Distance over time. So 210 kilometers divided by, 3.5. You know what? Let's go ahead and just make that a decimal, 3.5, because I think it's going to be a little bit easier to divide by decimals at this point than it will be to divide by fractions, because I know for a fact I haven't taught you that yet. So let's go ahead and divide 210 by 3.5. I don't know if we'll need a decimal or not yet, but I do know we need to move that decimal over one place. So let's erase this, since we're moving the decimal that's right here over here, then this number needs to become 2,100, okay? And then this number needs to become 35. Because remember that we need to make that divisor a whole number. Okay, so let's just guess here. I'm going to guess that 35 goes into 210 about 6 times. 6 times 5 is 30. 6 times 3 is 18, plus 3 is 21. I have a remainder of 0, and I bring down that other 0. 35 goes into 0 times. And I'm good to go. So my speed is going to be 60 kilometers per hour. All right, that is it for this video. Hopefully you have a really good pulse on speed. We've been doing some really difficult problems, and you should give yourself a pat on the back if you've been able to do these. Good job.